Hi everybody, this is Sam Hin with NLCAA, and today we'll be talking about the 2019 Title 24 Control Requirements for Outdoor Lighting, Section 130.2C. We start with this requirement that outdoor lighting shall be independently controlled from other electrical loads. Makes sense. We're not going to be mixing the controls of the outdoor lighting with the interior lighting. I mean, these will be treated separately. They have their own set of requirements. There are some exceptions for Section 130.2C, your controls for outdoor lighting, and these are the two scenarios that would be exempted from this section. First one being outdoor lighting not permitted by a health or life safety statute, ordinance, or regulation. And the other scenario is if you're doing lighting in tunnels that is required to be illuminated 24/7, 365 days a year. All right, so assuming we did not meet any of the two exceptions in the previous slide, our project continues to move forward here. We need to follow this first requirement. And this first requirement is all about daylight availability. You can see here we got some images. The sun is out. When the sun is out, exterior lights shall not be on. And how do we make sure that these lights are not on when the sun is out? Well, we could either use a photocell, or they call it photo control in terms of code. We could use a photocell that's external to the fixture, or it could be a photocell that's integrated into the fixture. Uh, both options I've seen on projects. Another acceptable method, instead of utilizing a photo control option, is utilizing an astronomical time switch. And all that is a time switch or a device that's able to predict time of day events based on dusk and dawn. And it accounts for geographic location, and it also accounts for calendar date. Obviously, that's important if we're going to do lighting controls without a photocell. We could use an astronomical time switch in lieu of a photo control. Okay. A lot of times, manufacturers that make time clock devices or have the capability of doing time scheduling will offer the astronomical capability, and I would say majority of them do. And if that is the case, you could just utilize that capability, and you'll meet this first requirement. Requirement number 2 for all outdoor lighting. Topic is automatic scheduling controls. Scheduling. I wonder what can do scheduling. Answer is time clock. So yeah, our lighting control system shall have a time clock, or the capability of setting schedules, which is a time clock. And so if we start looking at what we have to do with this time clock, this second statement here says automatic scheduling controls shall be capable of reducing lighting power 50 to 90% in addition to lights off during scheduled unoccupied periods. Now, one could read this and assume that, oh, shoot, we have to do dimming for the exterior lights to achieve this reduction, power reduction between 50 and 90%. And true, you could use dimming strategy to meet this requirement. But code never mentioned anything about dimming your exterior lights. All they're saying is just demonstrate that you're capable of reducing the lighting power. And so I can give you another way to reduce lighting power, and that's through switching off some of your switch legs, your exterior circuits. Code allows that. So if we are designing our exterior lighting and creating the zones and assigning the circuits to the different areas for the exterior, we just need to make sure we have enough switch legs, enough breakout of the circuitry that we can achieve this power reduction between 50 and 90%. Okay, code doesn't really go into much details, but the takeaway from this second statement is you could either use dimming strategy, or you could do it by circuits turning off. So next one, allow for 2 or more independent nighttime periods with independent lighting levels. Yeah, most time clocks will allow us to be able to do this, and this is just us demonstrating that our lighting control time clock or system is capable of creating 2 time schedules during the nighttime. So maybe, the exterior lights turn on at dusk, and then at midnight it goes to another schedule where the lighting, the lighting circuits or lighting dimming levels are at different levels. Or if we're doing circuits, maybe some of the circuits are off and some are on. So just having the capability of doing that allows us to meet this third requirement, or this third sentence. The last sentence here, it says may include an override switch for 2-hour max during scheduled off/dim period. So you're not required to provide an on-off switch for exterior lighting. That's not that's not a code requirement, but I would recommend it anytime we are controlling the exterior lighting. It's always nice to have an override switch. And this last statement here just indicates that during the scheduled off periods, you have to use no more than 2 hours max for override. So if you turn on the lights from a wall switch or from the switch during the off or dim periods, it can only be on for 2 hours. Okay, and if you want to keep it on for another 2 hours, then you'll probably have to go back to that switch and trigger it on again. Requirement number 3, motion sensing controls. Okay, so this requirement is can be a pain point for a lot of people, a lot of designers, contractors, engineers, and it applies to luminaires, exterior luminaires, where the bottom of the luminaire is mounted at 24 feet and under. Okay, it only applies to exterior hardscape. There are some exceptions here. So your exceptions would be lights that are being utilized as building facade, ornamental hardscape, outdoor dining, or outdoor sales frontage. And with this motion sensing controls, we're talking about the motion sensor being capable of reducing 50 to 90% lighting power in addition to off during unoccupied time. So they're talking about having that capability, okay? And most sensors, the way it works, motion sensors for exterior they'll just use a dimmable type motion sensor to dim the driver of the exterior light to achieve that low level step. Again, I like to call that low, high, low. So high being lights at 100%, when there's occupancy, and then when there's no motion, lights go to a low state. And so my low state, I'm saying, will be anywhere reduced by 50 to 9% lighting power. Okay, so now they're saying motion sensors shall reduce to dim level or off when unoccupied. So exactly what I just said. So lights will be at 100% when occupied, during the nighttime when it's dark, not during the daytime. And when there's no motion, beyond 15 minutes, the lights will go to a dim state. Okay, so 15 minutes is the max that's allowed for occupancy time delay. If you recall, the interior spaces allowed up to 20 minutes when you're using occupancy sensors for interior, but exterior we're limited to 15 minutes. All right, and then the fourth bullet here, it says no more than 1500 watts controlled by a single sensor. Okay, so they're just limiting you to how many fixtures you can have controlled from a single sensor. In most cases, you're not going to try to do one sensor, for up to 1500 watts. In most cases, we're looking to do a sensor per fixture. Okay, because most of these lights will be spaced out quite far from each other, and having a single sensor to detect motion when you cover much more area than what the sensor is able to cover when you compare it to the number of lights that are illuminating. It just doesn't make sense to do that. So what makes sense would be having lights that are that have the integrated motion sensors already in them, because that's a lot easier than running low voltage wires to do the dimming from your externally mounted sensors. So this slide right here does show you a couple of lighting fixtures that have the integrated motion sensors in it already. And again, the operation will be high-low when the lights are on during nighttime. And then the bottom statement here, wall packs installed for building facade, ornamental hardscape, and outdoor dining lighting are required to follow the requirements above. So if we're using wall packs for those types of applications there, then we too have to follow the requirements above with this motion sensor. What are the exceptions for this motion sensor requirement? Well, there's three of them. First one is if your luminaire is equal to or less than 40 watts, you can avoid this motion sensor requirement. Now, I would say that lights on a pole, most likely you're going to be over 40 watts. So, you're going to be looking for fixtures that have the embedded sensor already, or the integrated sensors already in them. But all the other lights, which could be, maybe you have wall packs, bollards, um, could be lights under a canopy, an exterior canopy, or downlights, I should call them. Those are all considered exterior hardscape lighting, and so it's all fair game for this motion sensor requirement. But those lights typically you can find under 40 watts, and you can still achieve proper illumination, safe illumination for those areas. So I say go after this exception if possible. If not, then try to look for fixtures that have the integrated sensors already in them to simplify, this need to have sensors installed in addition to fixtures. All right, so the second exception would be applications listed as exceptions to section 40.7a. We don't have this section listed in this PowerPoint slide, but just to give you an idea of some of the areas where that are listed under 140.7 would be lighting for like public monuments, lighting of signs, temporary outdoor lighting. So I recommend if you're looking for exceptions for this motion sensor requirement to maybe just look at that table or look at that section and see if maybe your application could use that exception. And then the third one is just lighting subject to a health or life safety statute, ordinance, or regulation would exempt you from this motion sensor requirement. And that concludes our lesson for today. Thanks for tuning in. Come visit us at nlcaa.org for more information.